Hello everyone, I want to pick up where I left off on linear equations. And I want to focus on number 2. You guys are responsible for the rest of those problems. I'll read 2 briefly. Speedy Printing charges $23 for 200 deluxe business cards and $35 for 500 deluxe business cards. Assume the cost is a linear function of the number of cards printed. For A, find a linear formula for the cost as a function of the number of cards printed. What information does the y-intercept convey? Using the function from part A, determine the cost for printing 700 cards. Now, oftentimes within the problem, they'll give you a hint as to what's occurring. Well, here's the first hint. They say that it's a linear function, right? So we should be able to have 2 points and a line running through them. And then it'll also say something along these lines. So it might say, write the blank as a function of blank, or give blank in terms of blank. So whatever you see in this very first empty space is always going to be your y, or your dependent variable. Okay, so let me zoom out for a minute so that you can see what I've written. Okay, and then what you see here is always going to be your independent. And what goes here is always going to be in your x position. Okay? So if we look closely at what they've given us, it says assume the cost is a linear function of the cards, right? So that's incredibly helpful because now we know that the cost has to be in the y and the cards has to be in the x. All right, so our goal now is to write those 2 points down. As I mentioned, we are going to put the cards in the x, and we're going to put the cost in the y. So there's the setup. So they say 200 cards is matched to $23 of cost, and they also say that 500 cards is matched to $35 of cost. Okay, so let's get to finding the equation of the line that runs through those 2 points. As I mentioned, you need to have a slope and a point. We have 2 points that the line is running through, so we just need to get to the slope. The slope is 35 minus 23 all over 500 minus 200. Okay, so 35 minus 23 is 12, and then 500 minus 200 is 300. Okay, so I tend to like to put things in a decimal. It's just a preference of mine. So if you prefer to leave it as a fraction, by all means, feel free. So I got that this was 0.04. All right. So as we had in the example from the previous video, we want to write this in y equals mx plus b form. Unfortunately, in this class, you have to place things in context, so I'm not going to be able to use this y. The x is going to be fine because it's still a quantity of cards, right? But the y, I have to be careful to acknowledge that this is the cost. So I'm going to say c of x equals m times x plus b. Again, where the c of x is your cost equation, and that's primarily because your cost was where your y was. Okay, so let's get to it. 0.04. Either of those points will work. 500 here equals 35 here plus b. So 35 equals, let's see, 0.04 times 500. Is 20 plus b. Okay, I'm going to subtract 20 from both sides, and I get that b is equal to 15. It is of extreme importance that you show all of your work because you will be judged according to your demonstration of the mathematics that we're trying to communicate in the class. All right, so here's your cost equation. C of x equals 0.04 x plus 15. All right, so this says the cost when X cards are printed is going to be 0.04 times the number of cards that you print plus 15. So if I had to sketch this out, all right, so here's 15 here, and this is 0.04 over 1. So it says go over 0.04. I'm sorry, go over 1, sorry, because 1 is in the X, and then go up 0.04. So you would get some type of line that looks like that. That would illustrate this particular function. All right, so then we have to ask ourselves, well, what does this mean? What does the 15 mean? What does the 0.04 mean? Okay, so on the x-axis, let me clarify, this is cards. And then as we have labeled here, this is cost in dollars. All right, so at this particular point, you have 0 cards that are created, right? You haven't produced any cards, and yet you still have $15. So the question is, where's the $15 coming from? So hypothetically speaking, I was making business cards in Stevenson 121, and I had to give the university $15 just to rent the room. So before I even produce these business cards, I have to cough up $15. Okay, so this is a fixed cost that's not necessarily associated with the production of the cards themselves, but something has to be paid before the cards are made. So there is your fixed cost. Okay. In addition to that, we need to consider this 0.04. This is your variable cost in the sense that you are going to pay 4 cents for each card that's made. Look, 0.04 is the rise in the cost relative to 1 more business card. Okay, so I just answered from this problem. It says, what information does the y-intercept convey? Check. We just answered that. It is fixed cost. Find the linear formula. Check. We answered that. Came up with C of x equals 0.04 x plus 15. And then the last one, C, says, using the function from part A, determine the cost for printing 700 cards. Okay. So with this formula, this is the cost at X cards, but they're asking us to do the cost at 700 cards. So this is 0.04 times 700 plus 15. All right, so I'm gonna have to get my calculator out for that. And let's see. Put it up so you can see it and do it yourself. 0.04 times 700 plus 15, and I got $43. How do I know it's dollars? Because your cost is in dollars.